phenomena in space that are just as important. Space weather describes solar flares, coronal mass ejections, coronal holes, and geomagnetic storms. And recent findings have found they have a big impact on our planet. Presenting why you should be aware of space weather, please welcome up Joshua Hale.
Earlier this month, I went on the longest road trip I've ever been on. My wife and I traveled through Idaho, down into Utah, and went to Zion National Park. Gorgeous. Then we stopped by at the south rim of the Grand Canyon. Never been there. We got up at 4:45 in the morning just to make sunrise, and it was one of the best decisions of my life. We carried on to there, though, all the way down to Albuquerque, New Mexico. And the reason I went there was because I'm part of an online community that observes the sun and space weather every day, and they were having a convention. So I went down there with about 400 other observers, and we went to a conference with about 8 scientists that were presenting new information on space weather. So what is space weather? As he introduced, space weather consists of solar flares that shoot from the sun, coronal mass ejections, and also gamma radiation and deep space radiation that comes into our environment. So a solar flare is when the sun, having sunspots on it, they have a positive and negative sunspot, and if they get too complex and intermingle, they'll react and shoot off a solar flare off of the sun. Now, if this Earth happens to be in the path of that solar flare, it will hit our magnetosphere. Who here remembers or has heard of the Carrington event? In 1859, the Carrington event was the largest solar flare on record. Luckily, back then, our electrical grid wasn't set up that much, so when the solar flare hit the Earth, it didn't do a whole lot of damage other than causing some fires and affecting the auroras that happened. They came all the way down to the equator. It was said that it was bright enough to read a newspaper at night. So, along with these charged particles that leave the sun, they come and hit the Earth, come in through our magnetosphere, and then actually affect the Earth. Some of these effects include the electricity of these charged particles coming in, going through our atmosphere, then they go into the ground, and the Earth has all this added energy, so that added energy needs to be expended somehow. And that comes in the form of earthquakes, volcanoes, and typhoons. They actually get stronger. And so by watching and observing the sun and the activity that the sun's shooting off, you can actually watch the effect here on the planet. Not only does solar flares cause that, but coronal mass ejections, which is these holes in the fields of the sun. These holes shoot out a stream of charged particles. And so there's this stream going out, and when the Earth is coming around, it will come and hit this stream of charged particles, which then hits our magnetosphere and then comes down and affects the Earth along with human beings. So I want to describe a little bit of the magnetosphere, how the magnetosphere works, before I get into how it affects human beings. Our magnetosphere reacts to all this space weather. When there's a lot of solar flares, our magnetosphere gets bigger and stronger in reaction to it. When there's no solar flares, our magnetosphere shrinks and gets smaller and closer to the surface. That's a problem because the sun has cycles. It has high solar activity cycles and low solar activity cycles. And we're actually moving into a cycle of low solar activity. And so that means the magnetosphere is shrinking and getting closer and closer to the planet. The problem with that is when we get into, let's talk about that coronal hole that was shooting out the charged particles. When we come into that stream of charged particles, those charged particles are getting closer and closer to the surface and affecting us as human beings. This is an alert system that was created called a KP index. And when these geomagnetic storms come and hit the Earth, they translate through earthquakes, volcanoes, and storms, but also they hit us as human beings because we have electromagnetic fields ourselves. We're essentially radios. And so when these geomagnetic storms come, they can increase heart rate fluctuations, they can increase heart attacks, they can increase your blood pressure, increase the chance of seizures, migraines, anxiety, stress, and there's even documented cases that when there's increased space weather, hospital visits go up. Along with solar flares, all these come in and can flare up your migraines, cause visual impairment, emotional instability. And for the cosmic rays, as I said, with the magnetosphere shrinking and getting closer and closer to the surface, people who are taking airplane flights, passengers, they're actually more at risk to radiation because they're so high off the ground. And when there was a storm or cosmic rays coming in, they can actually get an unhealthy dose of radiation. So from this convention, I learned a lot about how the sun has a direct relationship with our planet. And you could go to spaceweathernews.com and observe live instruments that are constantly monitoring and watching the sun. And you can look for when the sun puts off activity, and then like 18 to 3 days later, it hitting the Earth and watching the effects translate through the Earth, earthquakes, volcanoes, storms, but also perhaps you might have noticed some of these syndromes that are unexplained, that are happening to yourself or to your close friends and family. So by learning about this and understanding how the sun works, we can take more control of our lives by understanding how things are directly affecting us.